All right, in the second part of 8.2, we're going to continue looking at confidence intervals of proportions and specifically how to find a sample size if you don't know it. All right, one of the last examples I did was a four-step process for you. And you need to know this four-step process because it is based on an AP rubric on how they grade these exams. So if you include your 4 steps, you will get your full points values on these questions. So here's the steps again. The first step is to state, and you're looking at what parameter do you want to estimate and at what confidence level. Okay, so when you define the parameter, make sure you put it in context. Don't just say proportion. Proportion of what? Be very specific. The second step is to identify, and you want to identify the appropriate inference method, which is test. Right now, the only one we have is the 1 proportion Z interval. And then you want to check the conditions. All of that is part 2 in plan. In the do step, if the conditions are met, and usually they are, perform the appropriate calculations, showing your work. And then lastly, to conclude, you want to interpret the interval in context. All right, so those are the 4 steps you're going to always use as you do an inference or any kind of test problem. Is it okay to use your calculator to calculate the interval? Absolutely, yes. In fact, here's your keystrokes. You're going to go to Stat, Test, and find Test A. You got to scroll down past the numbers to get to A, and it says 1 proportion Z interval. Now, don't use the 1 sample Z interval. Those are different. You want the proportion one, right? Ignore this one. You want the proportion. Now, what does this look like? Well, I'm going to go back to one of the examples in the previous videos. We had a p-hat value of 57 out of 102. Those were pennies. And it was a 99% confidence interval. So you need this information before you know what to put in the calculator. So when you go to 1 prop Z interval, here's what the prompts will look like. It asks you X and N and the confidence level. Notice it does not ask you for p-hat. What you have to know is that X divided by N is the p-hat. So in this problem, we actually had X and N. And we can plug those in. Now, X has to be an integer. You cannot put a decimal in there. So in the event, you have to calculate X. Make sure you round it to a whole number. So there's X, there's N in this problem, and then the confidence level, 0.99. If I hit calculate, here's what the output will look like. And notice it gives me my p-hat right here. So if I wasn't sure, I can check myself. So the top here, this is my confidence. This is my minimum. This is my maximum. Now, you still got to show work. Calculator's going to run all this mess right here for you, but you still got to show this kind of work right here. So I can see, what did you get for your Z-star value? What did you put in your formulas? And then the output comes right off the calculator. So then here's the new thing. How do you choose a value for N when solving? So how do you choose a value for p-hat when you're solving for sample size? Well, lots to think about here. Basically, how do I know how big to make N in real life? Like if they don't tell you how big the sample size is, then you have to work it backwards. Well, that brings up a problem because if you look at this, in your formula, you might know a confidence level, and that can give you Z-star. But if you don't know p-hat and you don't know N, then you got a problem. So how do you know what to use for p-hat? Well, a couple things. You can use a guesstimate p-hat that's based on a previous experience or study, and that would be stated in the problem. Or if the problem doesn't state a previous p-hat value or p-value, then we use a p-hat of 0.5. And this is the most conservative guess since it's the smallest margin of error for any value of N. So we're going to use p-hat of 0.5 if they don't give you anything else. So let's try one of these problems. Suppose that you want to estimate P, the true proportion of students at your school who have a tattoo with 98% confidence and a margin of error of no more than 0.10. How many students should you survey? All right, well, let's think through this here. There's my equation for margin of error, right? It tells me some information here that's helpful. But with no previous knowledge of students with tattoos, we have to use a p-hat of 0.5 to estimate the sample size needed to estimate the true parameter. They don't give us a p-hat or a p-value anywhere, right? So we have to use 0.5. What do they give us? Well, n is the unknown. Z star, we can find Z star like we've done before because it's a 98% confidence level. And we know our margin of error has to be less than or equal to 0.1. So what I'm going to do is take this equation and put less than or equal to 0.1. And I'm going to put in the values that I know. I know Z star is 2.33. And I know p-hat is this, and 1 minus 0.5 is still 0.5. Divided by n, my unknown, all of this. Now we're just doing some algebra to solve this. All right? So what did I do? I divided both sides by 2.33. And then, to get rid of the square root, I decided to square both sides. When I squared this side over here, the square root went away, and this side is squared. Now, the next thing I need to do is address the fact that it says n is less than a number. We don't want that. We want n to be greater than or equal to a number. So we flip it, basically. When you flip your inequality, these will flip as well. So we flip it, make the reciprocals of each side, and it will flip your inequality. All right? And I square this. So what I have next is I multiplied both sides by 0.5 squared. So I have this squared times 0.5 squared. And when I crank out my numbers, it looks like this. N is greater than or equal to 135.72. Well, these are students, right? I can't talk to 0.7 of a student. So to be on the safe side, I need to round that up because n is greater than or equal to this. So my answer would really need to be, we need to survey at least 136 students.